Okay, so now we're going to start looking at connective tissue. So we did epithelial tissue already. We said epithelial tissue was when we had a bunch of cells, right? We saw before a bunch of cells packed closely together. See how tight these are? They're held together by these cell junctions. Okay, so when you see a bunch of cells closely packed together with little extracellular matrix, epithelium. But when we think of connective tissue, this consists of widely spaced cells. Not so close together, they're separated by matrix. We call it ECM, or extracellular matrix. It's the most abundant and variable tissue in the body, and it's found all over. It can connect organs to each other. It does connect to the epithelium, right? It connects the epithelium to the rest of the body. It gives support and protection, physical support and protection, and even immune. So when I think of immune, I think the immune system. I think antibodies. I think blood. I think white blood cells. I think B cells, which make plasma cells, which make antibodies. So blood is connective tissue. It's liquid connective tissue, but it is connective tissue. It's also involved in the storage of energy and heat production. In parentheses here, I have adipose, which are adipocytes. These adipocytes are fat cells. Fat cells are really important to humans because they store toxins. The amount of fat cells that one has at puberty is the amount of fat cells you have to manage for the rest of your life. And at that point in time, they can increase in size and decrease in size. You can't get rid of the number of them unless you have liposuction. So they can hypertrophy, they can get bigger, or they can atrophy and get thinner. Fat cells are important. They are metabolically active. They're also part of the endocrine system because they release these pro-inflammatory cytokines. Meaning, if you have any inflammatory disease, the more fat cells you have makes it worse. That could be a problem. Fat cells store toxins, right? That's why farmers spray their crops with herbicides and fungicides and pesticides. And when the insect ingests that carcinogen, it kills the insect because they don't have fat cells. It goes right to its neural system and kills it. But humans, we have adipose. So when we consume foods with those poisons on it, those toxins, it doesn't kill us, not right away. Right? It goes into our fat cells, it stores the toxins, and little by little it releases it so that the liver can detoxify it, send it to the kidneys, and the kidneys can slowly excrete those toxins. Okay, movement is another major function of connective tissue, movement and transport of materials through the blood. So red blood, white blood cells, all still connective tissue. Now, it's important to know these different classifications. I'm going to go through these slides and then I'll come back to it just to show you the key topics. So we have connective tissue proper, where we have loose connective tissue proper, and if there's loose connective tissue proper, there's going to be dense connective tissue proper. So we have loose connective tissue proper, dense connective tissue proper. We have fluid connective tissue, where we have blood and lymph. We have supporting connective tissue, like cartilage, hyaline cartilage, elastic cartilage, and fibrocartilage. So if I try and go through this just a little quick, I want to find this one slide here, and then we'll come back. Here we go. So when we look at connective tissue, right, there's connective tissue proper, which is loose and dense connective tissue. And under loose, I'll cover areolar, adipose, and reticular. Under dense connective tissue, there's regular, irregular, and elastic. Then we have supporting connective tissue, which is cartilage, and we'll go over hyaline, elastic, and fibrocartilage. And under supporting connective tissue, there's bone. We'll talk a little bit about compact bone. And then fluid connective tissue is blood. There's also lymph as well, but red blood cells and white blood cells. Okay, so now that we went over these main categories, so under loose connective tissue, there's areolar connective tissue, adipose, and reticular. Areolar is the padding that separates the skin from the deeper tissue. So if you were to pinch your forearm, you can pinch your skin and it separates it from the muscle. That's areolar. It's made up of elastic and collagen fibers. These are different types of proteins. Collagen is a very strong type of protein. It gives a lot of the tissues their strength, whereas elastic is like elastic. It allows it to stretch, but also to recoil back. Adipose, these are fat cells. Fat cells have a nucleus that's not centrally located, but it's off to the side. And then we have reticular connective tissue, which really provides the framework for many of your organs. So that's loose connective tissue. Dense, we have dense regular connective tissue and dense irregular. Dense regular is like tendons and ligaments. So what's a tendon? A tendon is just an extension of muscle. How does a muscle attach to bone? By tendons. Muscles contract. They transmit their contractile force into the tendon, and the tendon attaches to the bone, and then the bone moves. That's how muscles are involved with movement, through the tendon attaching to the bone. So tendons are the middleman between muscle and bone. Ligaments attach bone to bone. Okay, so when you have two bones coming together, ligaments hold them in place. When you stretch a tendon beyond their normal anatomical limit, we call it a strain. When you stretch a ligament beyond their anatomical limit, we call it a sprain. So strains and sprains are not the same thing. Strains involve muscles and tendons. Sprains with P involve ligaments. Dense, irregular connective tissue, we think of the skin, not the epidermis, but the deeper layer, the dermis. And then we have elastic connective tissue. When I think of elastic connective tissue, we'll find that within certain ligaments, especially ligaments of the vertebral column. The vertebral column is quite stable. The way the bones are articulated with one another, they're stable. They don't dislocate very easily. They can misalign subtly, but they really don't dislocate unless there's some major trauma. So the spine, however, is very flexible. It can bend and twist and move. So the ligaments of the spine have to have elasticity to them. We look at fluid connective tissue. Now we're talking red blood cells, white blood cells, and platelets. So red blood cells are known as erythrocytes. They're going to carry oxygen, carbon dioxide, and nitric oxide. Those are the gases. White blood cells are leukocytes. Erythro means red. Leuko means white. Like when someone has a white tongue, they call it leukoplakia. White blood cells are the warriors. They help us fight infection. Then in blood, we have platelets. Platelets are involved with clotting or creating what's called a thrombosis, which is the clotting mechanism. When you have a cut and you bleed, platelets help you clot. Okay, then we have lymph. Lymph is the interstitial fluid, and interstitial fluid, remember, is found between cells. It's also known as extracellular fluid. So it's that fluid that's found between the cells of the human body, and they're entering these lymphatic vessels. Okay, so that was fluid connective tissue. Let's go back and see what we've covered. We did loose connective tissue, dense connective tissue, fluid connective tissue, and then we're doing supporting connective tissue, cartilage. Now, cartilage is avascular. When I think of cartilage, I think of someone's knee where they have the meniscus, whether it's the medial meniscus, lateral meniscus, the cruciate ligaments, and the collateral ligaments of the knee. Not the best blood supply. So they say it's avascular. Vascular means blood vessel. Whenever you put A in front of the word, it means without. So avascular means poor blood supply. Cartilage doesn't have a good blood supply. So when you damage cartilage, it takes a while for it to regenerate. The three fibers that we have for cartilage is hyaline cartilage, elastic, and fibro. Fibrocartilage is like the strongest. Your intervertebral discs, fibrocartilage. Pubic symphysis, which is like a vertical disc where the pubic bones are, that is fibrocartilage. Elastic cartilage allows for flexibility. You have elastic cartilage in your ear, your nose, the eustachian tube in the ear, the epiglottis in the throat, in the lungs. There's lots of elastic tissue. Hyaline cartilage is found at the end of freely movable bones. So in between your fingers, your finger joint is hyaline cartilage. Between the wrist, between the elbow, between the shoulder, between the hip, the knee, the ankle. Anytime you have two bones coming together and you can voluntarily move them, there's going to be hyaline cartilage there. So it's going to cover the ends of bone's surface. So now this was a drag and drop not long ago where you have to choose between elastic, fibro, and hyaline cartilage. So which type of cartilage is composed of a networking of branching elastic fibers? Well, elastic cartilage is elastic. Which is composed of type 1 collagen fibers? They're very thick and they're parallel to one another. That's fibrocartilage. Hyaline cartilage is composed of type 2 collagen fibers. A lot of the nutraceuticals that I have in my office, I give to patients that have some arthritis or degenerative joint disease. These have type 2 collagen fibers to help regenerate those joints. Okay, showed up not too long ago. It's asking is the highlighted portion. Now, highlighted here is which color is different than the rest. Everything is pink, 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 but this is like greenish, right? Or like aqua color. So these are the cells right here. These are hyaline cartilage cells. But what we see around it is the extracellular matrix. So this blue is the matrix of the hyaline cartilage. Okay. I'm going to talk about bone, right? Bone is still supporting connective tissue. You're going to hear these words like periosteum, osteon, osteoblast, osteoclast, osteocyte. These are really important cells. Osteoblast with a B, that produces the matrix. That's going to form bone. Okay? When an osteoblast is producing matrix, if I'm an osteoblast and I'm producing calcium salt, these calcium deposits, think of it as cement, eventually the cement that I'm creating is going to harden. And it hardens, calcifies, or ossifies. The osteoblast, I'm going to get trapped in that matrix, but it hardened and now can't get out. I'm trapped. I'm in this cavity. I'm in this space. I now evolve from an osteoblast, become an osteocyte. Okay, I go from this osteoblast cell into an osteocyte. From producing matrix to I can't produce matrix anymore. The cavity that I'm trapped in is called a lacuna. It's called a lacuna. Osteoblasts make the matrix. The osteoclasts break down the matrix. Kind of like building up bone, breaking down bone, building up bone, breaking down bone. Anabolism, catabolism, building up, breaking down. Osteoblast, osteoclast. When you are breaking down bone faster than you can build it up, that's called osteopenia or osteoporosis. Osteon is only found in compact bone. Compact bone, let me see if I can show it to you. Here's a bone. Compact is here, the shaft. This is compact on this side. This is compact on this side. The ends here and here, this is more spongy. On the inside here is also spongy. So here's the periphery of the bone. This is compact here, and on the inside is spongy. These looks like cut a tree down in half, and you have these concentric rings. This entire thing with 1, 2, 3, 4 so concentric rings, that's osteon. This is an osteon. This is an osteon. 1, 2, 3, 4, 5, 6, 6 full osteon. Each of these are what we call concentric rings. This is a concentric ring. This is a concentric ring. Remember I said bones can be made and broken down, osteoblasts and osteoclasts. They get broken down. We have remnants of these osteons, and they're also called mellae. They're called interstitial mellae. So here, let's see if they have. Number 10 is interstitial mellae. So here's an osteon. Here's an osteon. Osteon. See this? 1, 2, 3, 4, 5, 6, 7, 8 little osteon. Here's another and another. What we see in between them are remnants. They're remnants. Look at number 10 here. These are called interstitial mellae. That's because osteoclast breaking some of them down. Okay. Notice how vascular bone is. There's arteries, there's veins, and there's nerves. That's why when you break a bone, it hurts. There's nerve supply to bone. Bones can bleed. When bones bleed, you can get like a blood tumor within bone. They call it a hematoma. These are lamellae. You can see again, they're concentric lamellae. Centers, or we have the central canal or the Haversian canal. That's where the artery, vein, and nerve are. Okay. The outer part of the bone, called the periosteum, it's down here on the bottom right. This is the periosteum, the outer layer. This is where, excuse me 1 second. I just don't want my battery to die. Give me a moment. Okay. Let's try this. There we go. Okay, so periosteum is on the outer portion. This is where your ligaments attach and where tendons attach. Okay? Tendons and ligaments attach to the periosteum. There's an endosteum, which is inside. Here's the endosteum. Okay. This is a bone model. Again, has the same bone landmarks. Look at the outside here. That's periosteum, number 3, periosteum. And then here, 13 is the endosteum. This is a spongy bone on the inside. This is all compact bone over here. All compact bone. Then you have osteons, have your Haversian canal, where the arteries, you see them right in the center there, number 9, the central canal. Here, what do you think the structure is? Take a look at your choices. When you look here, your choice is going to be, could it be lacunae? Remember, lacunae are these cavities, these hollowed out cavities, which is where osteoblast got trapped. Osteoblast gets trapped and it becomes an osteocyte. That cavity here, 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 for lacunae. Central canal is here in the middle. So this entire highlighted structure is an osteon. So now the highlighted structure here, the lacunae. That's where your osteocytes are. Okay, the connective tissue, most connective tissue is vascular, but we said cartilage, not so much. We said it's avascular. Tendons, so-so. Tendons, so-so. Ligaments, so good. So I would say tendons have the best blood supply of these 3. Ligaments come in second place, and the worst would be cartilage. Okay, okay, we're going to take a break, come back, then we'll talk about 3 types of muscle.